You are welcome to the GMAETS 41's live stream section. In this class, we are going to give attention to qualitative analysis, salt analysis, okay? I'm sorry that I'm some minutes late, just trying to set up, what is required for us to kick off the class. So you are, once again, welcome to the class. Please, if you can hear me, kindly indicate by dropping a message, I can hear you, so that we can kick off, okay? Welcome, the friends here already. All right, Manuel, you are welcome. I hope I can kick off now, right? Okay. So let's get to business. Okay? We are going to give attention to salt analysis, like I said, qualitative analysis. It is another part of chemistry practical where examiners can test students on. Now, in the morning, we treated something about titration. More of titration work will still continue, hopefully tomorrow morning, because there are some other questions I would still wish to give attention to. All right, but quickly, I want us to really give attention to this concept of salt analysis. As we kick off this, I want to first of all remind us that there are two basic videos where I gave a breakdown and or summary of what students should know about color changes, reagents that are used for certain ions. Please, dear friends, while you prepare for your salt analysis examination, there are two key points you want to bear in mind. If you have not done this, I urge you to use this little time left tonight to work on these things. I have these video lessons, one on cations, the other one on anions. Just go through the GMAETS 41's Chem 107 playlist. You will see those two videos. Watch them. Take the lessons there. Now, while you are taking these lessons, what should be your focus? Pay good attention now. 1. Memorize the reagents used for basic salt analysis, which includes sodium hydroxide and ammonia, basically. Then these ones are used to test for cations. Are you getting those positive ions like calcium ion, zinc ion, lead-2 ion, aluminium ion? We talk about copper 2 ion, iron 2 ion, and iron 3 ions. So these reagents, sodium hydroxide, ammonia, are used for them mostly in this experiment you're going for. Then we have this one you also want to give attention to. It is a special reagent which is used to confirm the presence of lead. This reagent is potassium iodide or potassium tetraoxochromate 6. That is KCrO4. So you want to take note of this reagent, okay, for cations. Then for anions, negative ions, reagents we use for them basically includes hydrochloric acid, which is used for testing CO3-2-, that's trioxocarbonate, for ions. Then we have this one that is used for testing chloride ion, which is silver nitrate or lead-2 trioxonitrate 5, okay, together with ammonia. Ammonia is used to check whether the precipitate will dissolve or not, as the case might be. And then for the sulfate ion, SO3-2- and SO4-2-, specifically we use barium chloride and hydrochloric acid, dilute form. Instead of barium chloride, you can use barium nitrate. Are you following, right? So, dear friends, make sure you memorize these reagents. Get to know them. I will tell you the reasons why you need these things. Are you following, right? Let us now say that you have known this reagent, and I've told you two videos have been on this channel since, okay? I think that should be more than a year now. That step by step, I explained what you should know about these reagents. Secondly, the ions that these reagents are used for. what is the observation? When you talk about the observation, here we give attention to color changes. Are you getting me right? Color changes. You are expected to know these color changes theoretically, so that by the time you enter exam hall tomorrow and beyond, when you are carrying out these experiments and you are seeing this color change, you will not be thinking, what is this? What is there? And other things. Already your background knowledge, theoretical knowledge of all these color changes will already help you to know what you are testing for. If what you're expecting does not show up, it now means that the ion you are suspecting is absent in that case. So these are two key points you want to give attention to. Please, I repeat, 1, get to know the reagents you use to carry out the test. Then 2, get to know the color changes in the process. Here in this class, we are going to make a summary work of them. Are you getting me right? We're going to make a summary work of them. I have this question I would like to dictate. I have this question I would like to dictate. Is that okay? It's a seemingly exam question. So follow along as I dictate this question. Follow along as I dictate it. Then after dictating, we'll analyze it, assuming we are in the laboratory. The truth is that to an extent, the instructions given to you, the questions, if you really read it very well, it can help you to predict, yes, to a certain level of 90% accuracy, what that ion really is there. But somehow, unfortunately, we might not have the whole time for me to break down all these concepts, so that this video will not be too long. In our physical classes on campus in UNIZIK, I've actually break down this concept. All right? But let's see how far we can go. Now listen to the question. You are given a simple salt labeled XN. You are given a simple salt labeled XN. Full stop. Dissolve the salt in about 10 cm cube of water, the distilled water that will be provided. Dissolve the salt, that is XN, in about 10 cm cube portion of water. It is not absolutely necessary to measure that 10 cm. You can just add up. I follow, you know. You can use your IQ for that. All right. Dissolve the salt in about 10 cubic cm of water before dividing the solution into 4 equal portions. Before dividing the solutions into 4 equal portions. To the first portion, add sodium hydroxide in drops. To the first portion, add sodium hydroxide in drops, then in excess. To the second portion, add ammonia in drops, that is aqueous ammonia because it's solution. Add aqueous ammonia in drops, then in excess. To the third portion, add barium chloride. Followed by dilute HCl. Add barium chloride followed by dilute HCl. And to the last portion, that is the fourth portion, add silver trioxonitrate 5. Add silver trioxonitrate 5 solution followed by aqueous ammonia. Record your observations and draw your inferences. As to the cation and anion present or absent. Identify the salt and write the IUPAC name. So that's the question. Now you see, I didn't have the reagents here to perform the live experiment for you to see. But the truth of the matter is, with the reagents given here in the question that you should add this, you should add that, the reagents can give us a certain knowledge of up to 80 to 90% idea of what the anions and cations likely are. The reason for this is because, yes, we know that sometimes an examiner can give you a question where you test in the negative direction. What do I mean by the negative direction? You test and then what you are expecting is not there. Maybe the thing is absent. But then let me now tell you something. It is not possible. Yeah, it is not possible. Even if anyone does it and I get to see the person, I will question the person. It is not possible that you go to the lab, for example, the exam you are going for, and then the examiner, the instruction they gave to you is such that as you are testing, everything will be absent. It doesn't work that way. That is to say, you have a negative result, which is absent. You are expecting that, okay, with this reagent given, this is what I'm expecting to be there. And then at the end, that one is absent. Another one you add, what you're expecting is not there, absent until everything is absent, is not done. You see, the experiment you are going for is such that they expect you at the end of everything to confirm the presence of at least some ions there. And this is the reason why, like I said, to a greater extent possible, one can predict the ions present in the given salt sample, right? Even without carrying out the full experiment. Yes, one can predict. However, I am not saying you should not carry out the experiment. You want to carry it out as much as there is time. But if you are choked with time, use the knowledge of the name of the reagent you are adding to help you predict the ion that is there. Having given this background, please, let's get to this work now, so that as I'm analyzing this, you would actually get the concept of what we are doing. Now we are to dissolve the salt in about 10 cm cube of water before dividing. So the first part, I can decide to say, number one, it's going to be XN, which is the salt sample XN plus water H2O. Now I expect that this salt XN will be soluble in water. I expect that to be soluble in water. This is the reason. If it is not soluble, right, in that question, the examiner would likely tell you to filter, maybe dissolve and filter. Once you hear dissolve the salt and filter, it means that that salt is a mixture of soluble salt and insoluble salt. So we can now write in the observation, salt so is partially soluble in water. And then the inference would be salt so, for example, in our case, XN, is a mixture of soluble and insoluble salt. But you see, in this our case, in the instruction, the examiner did not tell us to filter, which simply means that to a greater extent, salt XN is a completely soluble salt. And I'm going to work in that direction. When you are in the lab, please, as you dissolve, you watch. If it is completely soluble, right, the salt which is given to you would dissolve. Okay, let me use the word, will disappear inside the water in the test tube and become a colorless solution. If that salt is a white salt, what are our white salt? Calcium ion, zinc, calcium salt, zinc salt, aluminium salt, and lead salt. They are white, these four guys. Then copper 2 ion, iron 2 ion, iron 3 ion. You don't have problems with that. Yes, you don't have problem with those ones. Those ones are colored ion. Copper is blue. Are you following, right? Iron 2 is green, dirty green. Iron 3 is brown. So with the colors, you are safe there, right? Where you might have challenge on is these four other guys that are white. But if you take that video lesson I said, I broke down all those concepts. We're going to work in this direction and see, okay? So since we're not told to filter, it simply means I feel that salt XN is soluble in water. Then the inference would be that XN is a soluble salt. XN is a soluble salt. Is a soluble salt. One can write this salt XN dissolved in water. I think let me use that. It's an observation, so it's meant to be like salt XN dissolved in water. Yep. Remember why I decided to go in the direction of the fact that salt XN dissolved in water. I use that statement because we are not told to filter. And the fact that we are not told to filter likely means that that guy is completely soluble. So salt XN dissolved in water. Don't forget what I said. If you were told to filter, the observation here would be that salt XN is partially soluble in water. This one, since we did not specify that it is partially soluble, we just say dissolved. It means completely soluble. All right? Okay, we are moving on. We are told to divide this solution here now into 4 portions and then carry out various tests. You can look at your own instruction if you copied the question down when I was dictating. To the first portion, add aqueous sodium hydroxide in drops, then in excess. If I am in exam hall, what I will do first is just to read this through quickly as fast as possible. The reason is because the way the examiner gives you the instruction and where the instruction terminates, where it ends, helps you to an extent also to predict whether a particular salt or a ion rather is there. So if you look at with the reagents, sodium hydroxide and ammonia, that one of ammonia, when they mentioned it, the information about ammonia stopped there. They now moved on to, the use of barium chloride. Barium chloride already tests for negative ion. Barium chloride already tests for what? Negative ion, SO3 minus and SO4 minus. So you want to bear that in mind. Which means if I were to be in exam hall, looking at this, since I saw something like barium chloride, my mind will now start going to SO3 trioxosulfate 4 ion. Are you following right? And then SO4 2 minus, which is tetraoxosulfate 6 ion, because I saw barium chloride here, followed by dilute hydrochloric acid. Again, I saw silver trioxonitrate 5, AgNO3, followed by ammonia. That reagent is used to test for chloride ion, Cl minus. So the fact that I know what the reagents are used for, I already know what I am looking at. It is not left for me to carry out the experiment if my observation during the experiment does not agree with what I know in theory. I can now say that that particular ion is absent. But if my observation agrees with what I know in theory, I will now conclude that that particular ion is present. Don't worry, just follow along as I analyze this step by step. But I'm going to be targeting something. In the first portion of the solution, let's give it as number 2. Or let's give it as number 2. First portion of solution from 1 above plus aqueous sodium hydroxide in drops and excess. In drops and excess. Now, this sodium hydroxide is used to test for calcium ion, zinc ion, lead ion, aluminum ion, all right? It's used to test for this guy, and then ammonium ion NH4 plus. Sodium hydroxide is used to test for them. Are you following? So when you are preparing for this your exam, tonight, for those that have the exam tomorrow, you are meant to know the color, the behavior of these 4 ions I mentioned, even 5 ions anyway. You are meant to know their behavior with sodium hydroxide. That will now guide you so that when you are running the experiment, you know what you are targeting. Okay, this reagent is used for these 4 guys. Depending on what you observe, it will help you to conclude, to infer what actually is there. But see, for this particular question, there is something I am saying. After they ask us to add sodium hydroxide to the first portion, to the second portion, they say we should add aqueous ammonia. we should add aqueous ammonia. There are two major things I'm suspecting here, seriously. One of it is calcium ion, Ca2+. This is because of what I know about how calcium ion behave with this guy. Then the second one I'm suspecting seriously is zinc. Zinc, Zn2+. Now somebody may wonder, why is it that GMAETS41 is suspecting this guy? If you take note, I didn't think about lead. I did not think of aluminium. This is my reason. When they say we should add sodium hydroxide, after that one, the second portion we're asked to add ammonia. Ammonia is the confirmatory to check the presence of calcium ion. In that case, there will be no visible reaction. If you put that salt, that portion rather, that first portion, if you add ammonia, if it is calcium that is there, nothing will happen inside that test tube. The way that solution was, the first portion, before you add ammonia, that is the way it will remain. Let us assume that the first portion of the solution is colorless, because usually I'm expecting that possibly this salt is colorless. If likely it is a salt of zinc, lead, or aluminum, or calcium in that case. If you dissolve it in water, it's going to give you a colorless solution. Then you divide into 4 portions. But if it is a colored ion, like copper ion, maybe copper salt, iron 2 salt, or iron 3 salt, are you following? Once you add that water in the first instruction, you will see the color appear. Like I said, if it's a copper salt, you see blue. If it is iron 2 salt, you see dirty green. If it is iron 3, you see brown. So those ones are not a problem. I won't even analyze anything much on them. I won't. Are you getting me right? I've told you the reason. So coming back to what we have here, since we are told to add sodium hydroxide to the first portion and then to the second portion, add ammonia. Dear friends, I am 100% certain, I repeat, I am 100% certain that the salt that you have there is a salt of either calcium or a salt of zinc. It will not be lead and it will not be aluminum. As a matter of fact, to 95% confidence, I can tell you that they won't test you on aluminum. Yeah, the reason is because the reagent used to confirm aluminum, concentrated hydrochloric acid. I am pretty sure your examiner will not want to expose any one of you to risk. Are you following? So most times, exam bodies, what they do, even though during your laboratory work, all those weekly report stuff, you might have done something like that. It's possible, I don't know. But in main exam, where each student is expected to carry out that experiment, most times, examiners do not usually want to expose students to the risk of using concentrated acid. So even that of aluminum, like I said, 95 to 98%, I am sure you guys will not be tested on this. Except, maybe as I've said it, if the lab technologist shares it, they might decide, it's okay, let's do this. But anyway, until then, aluminum, half. Okay, what about lead? Why is it that I did not suspect or think that it is lead likely we are working on here? If it is lead, dear friends, this instruction, maybe the second portion, they will tell you likely to add potassium iodide or add potassium tetraoxochromate 6, because that is the guide that is used to confirm the presence of lead. Are you following, right? So if I had heard of that reagent, I could have been suspecting lead. Do you get that, right? So I am going to walk in the direction of the fact that it is maybe zinc. Let us walk in the direction of zinc first. If it is calcium, it is very simple for you to find out that, from your observation. I'll tell you when we write the inference here, assuming from what I've explained that it is zinc salt we are targeting here. So here, this is going to be white gelatinous precipitate. White gelatinous precipitate formed in drops. You must indicate in drops of sodium hydroxide, aqueous. It's a solution, so you put aqueous. Can put full stop. Remember, you were asked to add in drops and in what? Excess. So in drop is for you to see precipitate. Are you following? To find out whether precipitate is going to be formed or not. Then what will now happen in excess? In excess is to check whether the precipitate that are formed in drops, if it is going to dissolve or not. Remember I said I'm targeting zinc. So in this case, where I said I have white gelatinous precipitate formed in drops of sodium hydroxide, first up, then the precipitate dissolved. The precipitate dissolved in excess. Dissolved in excess of sodium hydroxide aqueous. It dissolved. Now, when you see this observation on adding sodium hydroxide in drops and in excess, this is the implication. Here, lead 2 plus and aluminium 3 plus suspected. Now, I'll tell you the reason why. The reason why we are suspecting this is because you see these 3 guys, they behave in the same way when you add sodium hydroxide to their salt in drops and in excess. Now, I am going to use this guy and hit calcium now. Are you following, right? So that once it is calcium in your laboratory as you're sitting for exam, you would know that it is calcium. Dear friends, if the salt is a salt of calcium, the precipitate will not dissolve in excess of sodium hydroxide. The white precipitate will not dissolve in excess of what? Sodium hydroxide. If the salt we are dealing with here, salt Xn, if the cation there is calcium. Which means, if you add sodium hydroxide in drop and you see the precipitate, and then you now add in excess, if you look at that test tube, right, that precipitate that is going to form will remain. It will look like white chalk. You know that chalk we use in writing on blackboard? It will look at white chalk dissolved in water. Chalk, can it dissolve in water completely? Like, is it soluble? It is not. If you pour chalk into water, you'll still be seeing that it is, if you like, shake it for how long you want. It will still remain that way. In that case, you will know that it is calcium. You just come here and write calcium present. Are you following, right? So that of calcium is very simple to detect or discover in the laboratory. So we are going in the direction that seems tougher, where we suspect these 3 guys. Like I said, these 3 ions, they will be soluble. Their precipitate will be soluble, will dissolve in excess of sodium hydroxide. Now let us move on. You are told to the third portion, add aqueous ammonia. To the third portion, add what? Aqueous ammonia. So I am going to write, is it section of solution? You must state where that solution came from. Of solution from 1 above. From 1 above. So that second portion plus NH3 aqueous. It is either you see it written like this, aqueous ammonia, or you see it written like this, ammonium hydroxide. Are you following, right? That is simply ammonia that is dissolved in water. So it is either written in this format or in this form. They are still the same thing. Take notes. So you are told to add this in drops and excess. In drops and in excess. All right. If you have any question, you can drop your question. Thank you very much, Emmanuel. I look forward to working with you next semester as well too. I know still get Chika. Please, you can specify if there is anything you don't get. Type your question and ask what exactly is confusing you. However, like I said, you see, there is a background to everything. If I said, okay, let me host this live class and state every single thing you need to know about this might take us up to 4 hours if care is not taken to break down all the concepts. That is why, like I mentioned, there are these 2 wonderful videos I've released where it is advised that all of you should take these 2 videos. Yeah, before tomorrow, if you have your exam tomorrow. There, I broke down all these concepts about reagents you use and color change. It's going to help you to follow up with this. Even I think in that video, I also explained how the instruction and where that instruction stopped can actually help you to know likely what is present somehow to an extent, even without carrying out the whole experiment. However, make sure you carry out the experiment, please. It's only when you are choked with time you can now apply. Okay, we are moving on. So, working with this, see, dear friends, the fact that your examiner told you to add in the second portion, you should add ammonia in drops and in excess. And then, the instruction terminated there for cation reagent. What do I mean by that? See, after this portion, the third portion, they say you should add barium chloride. Barium chloride is not used to test for cations. It's not used. The fourth portion, they say you should add silver nitrate and then follow it up with ammonia. Silver nitrate is not used to test for cations, the positive ion. It simply means that for cations in this experiment, the instruction terminated with the second portion. And because the instruction terminated with the second portion, and in that second portion, they said I should add aqueous ammonia in drop and in excess. There is only one thing possible here. If this salt XN, if the cation there is not calcium ion, if it's not calcium ion, which I told you already, if this guy were to be calcium ion, right, as we carry out the experiment, with this sodium hydroxide from there exactly, you would even know if it is calcium. With this guy, you will know that the cation there in XN is calcium. Why? The white precipitate formed here will not be gelatinous. It will not be gelatinous. 2. The white precipitate formed will not dissolve. That is to say, if this guy were to be calcium, are you following, right? The observation would be white precipitate formed in drops of sodium hydroxide. The precipitate remained insoluble, or the precipitate did not dissolve in excess of sodium hydroxide. And it is only calcium out of these 4 white ions, right? It's only calcium out of these 4 white salts. Because I mentioned calcium, zinc, lead, and aluminium. It's only calcium that will produce a precipitate which will not dissolve in excess of sodium hydroxide. So that one is not your problem. It's not. Based on what I've said now, at least, if you see it tomorrow or other days of your exam, once you add sodium hydroxide in drop and in excess, and nothing happens. Like, you get a precipitate rather, and then you add in excess, the precipitate did not dissolve. Simply, you know it is calcium ion, Ca2 plus. Okay, let's move on. Now, the fact that this thing terminated with ammonia, the test for cation here terminated with ammonia because of the reagents mentioned. It simply means that the salt that XN, the cation it contains is going to be zinc. I will tell you why. Out of these 3, white is going to be zinc. And what will be the observation? The observation will be white gelatinous precipitate. White gelatinous precipitate. I'm tired of writing precipitate fully, all those things. I'm going to abbreviate. But please, in your exam, don't abbreviate, write it full. White gelatinous PPT formed in drops of NH3 aqueous. So stop, then proceed. The precipitates, PPT, dissolved in excess NH3 aqueous. It dissolved in excess NH3, all right, aqueous solution of it. With this, I will now conclude here that zinc confirmed. Zinc confirmed. The reason, out of these 3 ions, it is only zinc that will produce a precipitate which will dissolve in excess of aqueous ammonia. Zinc, lead, aluminium will produce white gelatinous precipitate in drops. They will produce white gelatinous precipitate in what? In drops. but the precipitate, it is only that of zinc that will dissolve in excess of ammonia. So this is what we have here. Dear friends, there is something I want to do here before I write this issue of zinc 2 plus confirmed. I feel that because you added in drops, it is possible that when you added in drops, you looked at the test tube, you saw the white precipitate. For the fact that you saw white gelatinous precipitate in drops, before you could conclude that this guy is zinc, you can decide to write zinc 2 plus, lead 2 plus, and aluminium 3 plus suspected. Put full stop there. Then below you proceed and write zinc 2 ion confirmed. Zinc 2 ion confirmed. That is zinc ion confirmed. Why did I present this result like this? This first guy here, that the 3 guys are still suspected, is when you added the reagent ammonia in drops. Because on a normal, your examiner, some questions given, they can break this issue of add in drop and add in excess. They can break it down. Maybe the first instruction will be add in drops. The next question will be add in excess. So in drops, please take note that these 3 guys will produce white gelatinous precipitate with aqueous ammonia. But when you now add that aqueous ammonia in excess, only zinc precipitate will dissolve. And look at what I have here. The PPT dissolved in excess aqueous ammonia. And once that happens, you can now say that zinc is what? Confirmed. Let me now answer the question why I said what is there is not lead and what is there is not aluminium. The reason is simple. If it is lead that is actually the cation in this XN, the instruction will not stop. That instruction that makes use of reagents used in testing for cation, that instruction will not stop with the second portion. It won't. It will proceed to the third portion. In the third portion, they will still give you a reagent used to test for cations. And I put it to you that that reagent will be the reagent used to test for lead. That is, if this guy was not zinc. Why did I know that it is zinc? Because the instruction terminated. It terminated with addition of ammonia. Like I said, sodium hydroxide ammonia are used for cation tests. After that, the third portion was, I think, barium chloride is said. You have moved to anions there. Are you getting me right? So since this instruction stopped with ammonia here, very well, this is meant to be zinc. So when you are carrying out the experiment, you are seeing this thing happening, you should know what is there. But like I said, if this was not zinc, that it is meant to be lead, you must see that in another portion, you'll be told to add potassium iodide or potassium tetraoxochromate 6, because that is the reagent used specifically for lead. And let me say this, you can put it down because I'm not going to analyze that. If lead is present, if it was lead that is present in this guy, in the salt XN, when you add potassium iodide, or potassium iodide is this guy, let me write it out, wipe it, or potassium tetraoxochromate 6. If you add any one of these 2 guys, you will see a yellow precipitate. Once you add this to any portion and you see a yellow precipitate, that tells you that lead is present. But we didn't see anything like this reagents, so definitely it is not lead. It is not what? Lead. I can assure you of that. Like I said, this particular guy is either calcium or zinc. They won't bother you of aluminum, I've told you that. It's calcium or zinc. However, I decided to go in the direction of zinc